We count on AI search for, well, everything. But what if there's a fundamental hidden flaw in how it works? We're going to dig into a wild new paper from Google DeepMind that found a crack in the very foundation of modern AI.
Okay, let's just jump right in. We've all watched AI search become almost magical, right? It gets nuance, it gets context, it just gets us. But what if I told you it has a secret mathematical blind spot, one that makes it fail at tasks that would be, honestly, trivial for you or me?
So, what is this flaw? Well, here's the thing. It's not about needing more data or building bigger computers. Nope. The problem is much, much deeper than that. And let's be super clear here. We are not talking about your usual AI hiccups, when it gets a fact wrong. This is about a fundamental ceiling that's literally baked into its design, a hard limit that can stop it from understanding even the simplest of requests.
So to really find this flaw, we first have to understand the magic that powers modern AI search. It all comes down to a concept called the single vector embedding. It's a really brilliant idea, actually. The AI takes your search query, say funny dog videos, and a whole bunch of documents, and it turns every single one into a point in this massive, multi-dimensional map. If 2 points are close together on the map, it means they're related. That's how an AI knows that puppies and dogs are connected, without you ever having to tell it. Pretty cool, right?
But, and this is a huge but, the power of this geometric space, this embedding dimension, isn't infinite. It absolutely has its limits.
Think about it like this. Imagine trying to describe every single detail of a complex 3D sculpture, but you can only use a single one-dimensional line. It's impossible, right? You'd lose all the depth, all the nuance. Well, an AI's digital space works the same way. At some point, if you try to cram too much in, complex ideas get squished together, and all that rich meaning just gets lost.
And this isn't just a metaphor. Researchers actually calculated a mathematical breaking point. For a pretty standard model with 1024 dimensions, once you hit about 4 million documents, it becomes theoretically impossible for the AI to map out every possible answer combination. The system literally just runs out of room.
So a theory is one thing, but could they actually prove it in the real world? Oh yeah. To put these big AI models to the test, the researchers basically built a custom-made trap, a dataset they called LIMIT.
The test was so simple, it was almost sneaky. They created a bunch of documents like John likes quokkas and apples, or Leslie likes apples and candy. Then they asked the AI super basic questions like, find people who like quokkas. I mean, this is stuff any of us could do with a simple spreadsheet in like 5 seconds.
And the results were just stunning. I mean, the state-of-the-art models failed spectacularly. Get this, even when they were allowed 100 guesses, they found less than 20% of the right answers. They were completely and utterly baffled by a task a kid could do. It's just, wow.
Just as the researcher said, the failure was undeniable. This wasn't because the models needed a bit more training. No, this was a crystal clear demonstration of that theoretical limit we were just talking about.
So, what gives? Why did the world's smartest AIs totally faceplant on such a simple test? Well, the reason is actually completely counterintuitive.
The problem wasn't how complex the question was. The real issue, the secret sauce of the trap, was that the LIMIT dataset was built to have a massive number of interconnected results. So unlike normal data where answers are kind of predictable, here, any 2 items could be linked by a search. This created this insane explosion of potential answers the AI had to keep track of, and its limited little map, its embedding space, it just couldn't handle it.
Okay, so is AI search just broken? No, not at all. What this research really does is shine a light on the limits of one specific approach. And what's even more exciting, it actually points the way to a much, much smarter future.
See, it turns out there are other ways to build an AI search brain. You have these other architectures like cross-encoders or multi-vector models that don't have to squash everything into a single tiny point. And when the researchers tested these models on the exact same problem, well, the results were like night and day.
What you're seeing here is it's such a stark difference. On a smaller version of the test, the single vector models still really struggled. But just look at the cross-encoder using Gemini Pro, 100% correct. It totally aced the test. So here's the big takeaway. While those single vector models are super fast and efficient, they make a trade-off. They sacrifice how much they can understand for sheer speed, and this LIMIT dataset was perfectly designed to call them out on it.
The researchers' final point isn't that we should just scrap the current approach. It's that we need to be really aware of its limits. This isn't some death knell for AI search. It's actually a huge step forward, a step towards a more mature, sophisticated, and frankly, a more honest understanding of what these incredible tools can and can't do.
And that kind of leaves us with this one big provocative thought, right? As we keep building more and more of our world on top of these AI systems, understanding their fundamental limits isn't just for academics. It's absolutely essential for all of us. And it really makes you wonder, what other simple tests are out there just waiting to show us the true boundaries of what we thought was magic?